Hi, welcome to my video. Now in this video, we're going to do a problem solving on acids and bases, which involves the pH calculations. Now let us start with the statement provided to us. Let us read it first. Now they say to us, sodium hydroxide pellets are added to 500 cubic centimeters of H2SO4 solution with 0,075 moles. The balanced equation for the reaction is as follows. Sulfuric acid reacts with sodium hydroxide to form sodium sulfate and water. After completion of the reaction, the pH of the solution was found to be 1,3. Assume complete ionization of H2SO4. Calculate the mass of sodium hydroxide added to H2SO4 solution. Assume that the volume of the solution does not change. This is the question. Before we can go through this question for 9 marks, let us try to understand the whole statement provided to us before we can perform calculations. Now here, we have a beaker, okay? So here, we're gonna have a beaker. So here we have a beaker, okay? Now this beaker, it has a prepared solution, but this beaker, it has a prepared solution of H2SO4. Okay, our sulfuric acid. Now, the volume of this solution in this beaker is 500 cubic centimeters. But remember, we do not work with cubic centimeters, but we work with cubic decimeters. So let me just convert this first. So we know that 500 cubic centimeters, when we want to convert it, we know that 1,000 cubic decimeters correspond with 1 cubic. Sorry, I made a mistake. We know that we know that 1,000, let me fix that. We know that 1,000 cubic centimeters, it corresponds with 1 cubic decimeters. Now this and this, they're gonna cancel off, and therefore 500 divided by 1,000 multiplied by that, it's gonna be 0,5 cubic decimeters. So that means this solution, the volume of this solution will most definitely be equals to 0,5 cubic decimeters. This is the volume of the whole solution. Now we are also given the number of moles of the solution of H2SO4, which is most definitely equals to 0,075 moles, okay? So this is a prepared H2SO4 in a beaker. But now in this prepared solution of H2SO4, sodium hydroxide pellets were added onto this solution. So that means here in this solution, the pellets of sodium hydroxide were added onto this solution. But the mass of these pellets of sodium hydroxide, they are unknown. Hence why from the question, it says calculate the mass of sodium hydroxide added to the H2SO4 solution. So that means this mass, it is most definitely unknown, which is what we will be looking for. Now, when sodium hydroxide is added into this solution, this equation is true, whereby H2SO4 will react with sodium hydroxide to form these products. This is acid and base reaction, whereby salt and water has been formed. Now, after completion of the reaction, the pH of the solution was found to be 1,3. Now, this is what is happening. For this reaction to be complete, to form these final products, in the very same beaker, after completion of the reaction, remember, assume that the volume of the solution does not change. So that means the volume of the solution after addition of these two, it still remains to be 0,5 cubic decimeters, okay? Therefore, remember, after completion of the reaction, the pH of the solution was found to be 1,3. Now they are telling us about the pH of the whole solution, which is composed of sodium hydroxide and H2SO4. The pH of this solution now, it becomes 1,3. Okay? So now, this is all provided, or this is what is all given to us. But now let us re-emphasize on what is given based on these sketches that I've just drawn for you. Now, for a fact that the pH is 1,3, what does that tell you? What does that tells us? Now, from the principles, from the basics of acids and bases, we have learned that when the pH becomes less than 7, our solution becomes acidic. Now, for a fact that our pH in this solution is 1,3, that means the whole solution, it is acidic. Now, how would we see, or how would we know that the pH is acidic? Number one is because of the, how will you know that the solution, it is acidic? Number one, the pH is 1,3. And then again, we have high concentration of hydronium ions in this solution. So that means because of the pH is 1,3, which is acidic, that means we have this concentration, high concentration of H3O plus ions in this solution. Okay, right. The question is, what made the pH of this to be 1,3 amongst our reactants? Most definitely, it is H2SO4. So that means concentration of H2SO4 does also corresponds with concentration of H3O plus ions, since, well, the whole solution, it is acidic by means of its pH, which is 1,3. So that means the concentration of H3O plus ion will correspond with concentration of H2SO4. Okay, right. So now let us try to perform the calculations based on the information provided to us. Remember, we want to calculate mass of sodium hydroxide, but now let me give you some hints. How are we going to calculate that mass, okay? To calculate this mass of sodium hydroxide, we're going to use these formulas, stoichiometric calculations. We're going to use number of moles is equals to mass over molar mass. Okay, we're going to use this formula to calculate mass of sodium hydroxide. That means we're going to need number of moles of sodium hydroxide and the molar mass of sodium hydroxide to determine the mass of sodium hydroxide. But the question is, it's simple to get molar mass because we're going to use our periodic table. But how are we going to get number of moles of sodium hydroxide added? Now, this is how we're going to get it. Firstly, we need to know, since when we are told that assume completion of ionization of H2SO4, we need to know number of moles of H2SO4, okay? The first thing that we're going to do, we need to know number of moles of H2SO4 that has reacted with sodium hydroxide. Why? Because number of moles of H2SO4 reacted with this is going to help us to determine number of moles of the very same sodium hydroxide, so that we can plug that number of moles here and determine our mass. Okay, right. So now, how are we going to get, firstly, how are we going to get number of moles of H2SO4? Okay, we need number of moles of H2SO4. That's the first thing. That's what is in our minds. Okay, we need number of moles of H2SO4 reacted. Okay, we need number of moles of H2SO4 reacted. That is in our mind. So that this number of moles reacted, we can use them to determine number of moles of sodium hydroxide. Like I said, we like it here, we determine our mass. But the question is, how are we going to get this number of moles reacted? Now, let us utilize what is provided to us. Okay. Remember, initially, we were given number of moles of H2SO4. But be careful. This number of moles, it is not number of moles reacted. It is number of moles of H2SO4 initial. So that means we started with this number of moles, but out of this number of moles, which is 0, let me shoot here. Out of this number of moles of H2SO4, which is 0,075, there is a specific amount of number of moles that has reacted with sodium hydroxide. So that means this is a huge number of moles. So out of this, there is a specific amount of sodium hydroxide that has reacted, okay, which is what we are looking for. And therefore, obvious, not all of 0,075 it is going to react. That means there is another number of moles that it is not going to react. So that number of moles of H2SO4, we call it number of moles in excess. Okay, we call it the number of moles of H2SO4 in excess. Okay, we also do not know number of moles in excess. So that means this is what we are going to do. We only know number of moles of H2SO4 initial. Initial, it is 0,075 moles. Okay, so that means this number of moles we have reacted in excess. When we add this together, we get initial number of moles. So what we want from the start is this one. Okay, but we're gonna start with this excess. But how? Now, remember, what did I say to you? I said to you, after the completion of the whole reaction, we managed to form a high concentration of H3O plus ion due to pH which is less than 7. And I said to you, this pH will correspond with pH of our acid, which is H2SO4. Now, we're gonna calculate concentration of H3O plus ion using the very same pH. And therefore, this concentration will help us to determine the concentration of H2SO4 in excess, or the concentration of H2SO4 left out after reaction has been completed. So how are we going to do that? Now let's perform calculations. Now we start doing calculations. So that means we're gonna say pH of solution is equals to 1,3. But now, how do we calculate pH? We say pH is equals to, we say the pH is equals to, the pH is going to be equals to negative log times concentration of hydronium ions. And therefore, after determining the concentration of, sorry about that. After determining the concentration of, after using, sorry about that, I had a disturbance. So we're gonna substitute 1,3 over here, which is equals to negative log H3O plus ions. And therefore, we're gonna say concentration of H3O plus ions is equals to base 10 to power negative 1,3. Therefore, when we punch this on our calculator, 10 to power negative 1,3, we get 0,035 5 to 2 decimal places. But remember, this is concentration mole per cubic decimeters. Okay, that will be concentration of H3O plus ions. Okay, now we managed to determine this concentration of the solution after completion. So now that means we're going to determine the concentration of H2SO4. But remember, concentration of H2SO4, I said to you, it's going to correspond with concentration of, because this is acidic, concentration of H3O plus ions. But now, how many number of hydrogen atoms do we have of H2SO4? We have 2. So we're going to multiply this hydronium ion concentration by 1/2. Okay, if we had 3, we're going to multiply by 1/3. If we had just only 1 hydrogen, we're going to multiply by 1/1, which is the same as that. Okay, so that means concentration of H2SO4 in this case will be equals to how much? I'm gonna say 1/2 multiply by, remember we got 0.05, 0.05. And therefore, when we punch this on our calculator, I'm gonna say 0.5 multiplied by 0.05. We get 0.025 moles per cubic decimeters. Okay, remember this, it is concentration of H2SO4, right? Right. So now this is concentration of our sulfuric acid in this solution. But remember, this solution, this H2SO4, it is in excess, meaning this H2SO4, it is the H2SO4 that has left without undergoing the reaction. Okay, so that means this concentration and this volume, it is going to help us to determine number of moles of excess. Okay, we're going to determine this now. So that means we're going to say number of moles of H2SO4 is equals to stoichiometric calculation, C multiplied by V. Now our concentration in this case is equals to 0.025. And therefore our volume will be most definitely, remember, remains unchanged, 0.5 cubic decimeters. And therefore, I'm going to punch this on my calculator. I'm going to say 0.025 multiplied by 0.5, and then I get 0.0125 moles. Now remember this, it's number of moles of H2SO4 in excess. Do not forget that, okay? In excess. This is number of moles of H2SO4 in excess. Now, what are we going to do? Now we're done with this. We're going to determine number of moles of H2SO4 reacted now. So we're gonna say number of moles of H2SO4. I'll just write R to show it's reacted, will be equals to number of moles that we started with, which is 0.075, subtract the number of moles that are in excess, which is 0.0125. Okay, now when I punch this on my calculator, I'm gonna say 0.075, subtract the answer, it's gonna be 0.0625, I'm sorry, moles. Okay, so now these are the number of moles of H2SO4 reacted. Now we know number of moles of H2SO4 reacted. Now we can determine the number of moles using the balanced chemical equation. number of moles of NaOH that has reacted with this. So now, according to a balanced chemical equation, okay, according to a balanced chemical equation, we can see that we have one stoichiometric coefficients, okay? We have 1 mole of what? Of H2SO4, which will correspond with 2 moles, 2 mole of NaOH. And therefore, sorry about that, NaOH, and therefore, how many number of moles of H2SO4 has reacted with this? As we have determined, it's 0,0625 moles, and therefore, how many number of moles of this has reacted with that? This is what we are looking for. We are looking for number of moles of sodium hydroxide reacted. So we're going to cross multiply, okay? 1 multiplied by N is going to be number of moles of sodium hydroxide, which is going to be equals to 2 multiplied by this, okay? It's going to be answer multiplied by 2. I got, let me do 0,06625 multiplied by 2. It's 1/8, which is 0,125. I get 0,125 moles. Okay. Now I managed to get number of moles of sodium hydroxide. I can get my molar mass of sodium hydroxide and determine my mass. Okay. So let me go to the next page. So this is number of moles of sodium hydroxide so far. So let me manipulate this formula first. So we're gonna make mass subject of the formula, which is equals to number of moles multiplied by molar mass. Okay. Now, what is mass of sodium hydroxide? Number of moles of sodium hydroxide. It's 0,125. 0,125, and then what is the molar mass of sodium hydroxide using our periodic table? Using our periodic table, we're gonna say 2 multiplied by Na plus OH. So that means we're gonna say, let me go here, 2, and then what is our N? N is 23. Oxygen is 16, hydrogen I think it's 1, and we close this, and then let's determine the mass. So we're gonna say this answer multiply by 2 times 23 plus 1 plus 16, and then our answer we get, oh sorry, I was supposed to include this, okay, do not forget, we don't include this one, the stoichiometric coefficient, we do not include this one when we want to determine the molar mass, okay, do not forget that. So let me do this on my calculation. We're gonna say 0,125 multiplied by the sum of 23, 16, and 1. Therefore, we get 5. So that means our mass here is gonna be 5 grams. Therefore, mass of sodium hydroxide will be 5 grams. Final answer. Hope that is making sense.